Welcome dear students. In previous video we discussed about charging by induction and gold leaf electroscope. From charging by induction method we came to know that how we can make an uncharged body as a charged body without keeping a charged body in physical contact with the uncharged body. And also we got the idea about the gold leaf electroscope. By using the gold leaf electroscope, we can detect the presence of a charge on a body and also we can detect the polarity of that charge. Now we are going to discuss some concept. Before discussing that concept, we will learn some points related to the electric charge. Dear students, we know that electric charge is a physical quantity. We know that physical quantity is nothing but the any quantity that can be measured. To measure any physical quantity, we are using SI unit. SI unit is nothing but a system of an international unit. Similarly, for electric charge, we are using an SI unit. So that SI unit of electric charge is nothing but a coulomb. SI unit of electric charge is coulomb. And it is denoted as letter C. Okay, that is the SI unit of electric charge. And in general, we can denote the electric charge as the letter Q. That is the notation of electric charge. That is Q. For positive charge, we are denoting it as plus Q, and for negative charge, we are denoting as a plus Q, and for negative charge, we are denoting charge as a minus Q. For negative charge. So that is about the SI unit and the notation of a charge. Here the SI unit of electric charge is coulomb. Now how we can define 1 coulomb of charge? 1 coulomb of charge. 1 coulomb of charge is nothing but it is the charge that flowing through the wire in 1 second if the current is 1 ampere. Then it is called as the charge is called as 1 coulomb of charge. So 1 coulomb is nothing but it is the charge flowing through. It is the charge flowing through wire in 1 second. In 1 second, if current is 1 ampere, then we call charge as 1 coulomb. That means if I take an electric wire, okay, we know that the current is nothing but the rate of flow of a charge. So to get the current, the charge should flow through this wire. Suppose that if you assume that the charges which is flowing through this wire in 1 second, if 1 ampere of current produced by this wire because of flowing of a charge, then we are called the charge as 1 coulomb of charge. Okay, so that is the definition of 1 coulomb of charge. Okay, that is another point you should remember. And another point is nothing but point charges. What is the meaning of point charges? Point charges is nothing but size of the charges is small compared to the distance between them, then they are considered as point charges. That means if you take 2 positive charges, this is one positive charge and another positive charge. Okay, there are 2 point charges here and there is a distance between these two charges. Assume that distance as r distance. Okay. If the size of both the charges is very small compared to the distance between them, then both the charges are considered as point charges. Size is very small means the radius of this charge is very small compared to the distance between these two charges. Then it is considered as a point charge. Okay, that are some important points you should remember in this chapter. So next we will discuss the properties of charge. Basic properties of electric charge. Properties of electric charge. Charges has some properties. We will discuss about that properties one by one now. First property of electric charge is nothing but additivity of charge. Additivity of charge. So what is the meaning of additivity of charge? Additivity of charge gives the idea about the number of charges present in any body. Suppose that if any system or if any body consists of a number of charges, then total charges present on that body can be calculated by taking the algebraic sum of all the charges present anywhere on that system or body. Then that is called as the additivity of charge. For example, if I take one system or any body, okay, assume that this is an body and it is a charged body. Suppose that if it has 3 positive charges, that one denoted as plus q1, plus q2 and plus q3. All are the positive charges. Now how I can count the number of charges in this? So to count the total number of charges in this system, what I have to take is I have to take algebraic sum of all the charges present anywhere on this body. That means I have to add, that is q1 plus q2 plus q3. So total charge is equal to q1 plus q2 plus q3. Total charge present in that body. That is one of the property of charge. Suppose that instead of positive charges, it has some negative charges also. Minus q1, this is the negative charge. Plus q2, this is the positive charge. Minus q3, this is the negative charge. Now there are 3 charges are there, but these are different in polarities. Now how I can find the number of charges in this body? To do so, I have to take the algebraic sum of the 3 charges. That is nothing but minus q1 plus q2 minus q3. So this gives the total number of charges present in that body. That property of charge is called as additivity of charge. Okay, that is the first property of charge. Another property of charge is nothing but that is the conservation of charge. Conservation of charge. This is the another property of charge. What is the meaning of conservation of charge? Conservation of charge is nothing but total charge of an isolated system is constant. Then it is called as a conservation of charge. Okay, total charge of an isolated system is constant. We know that in our environment or in our surrounding, we will observe there are different conservation laws, right? For example, law of conservation of energy, law of conservation of mass. Similarly, there is a law of conservation of a charge. So according to this, what it tells that the total charge of an isolated system is constant. What is the meaning of isolated system? Isolated system means it is one of the system, and that system is non-conducting closed system. Okay, this is an isolated system, non-conducting closed system. If this system has charges, for example, this system has 1 coulomb, 2 coulomb, 3 coulomb of charges. Okay, all are positive charges. Assume that there are 3 charges: 1 coulomb of charge, 2 coulomb of charge, 3 coulomb of charges it has. Okay, now I am going to shake this isolated system. Okay, now I am going to shake this isolated system. After shaking, there is a displacement of charges takes place. Okay, here it may be 2 coulomb, here it may be 3 coulomb. Then what is the another value of charge? That one is very important. How to calculate the another value of charge? So by calculation, here see, it has a 1 coulomb plus 2 coulomb plus 3 coulomb. So here it has a 2 coulomb plus 3 coulomb. I don't know what is the another charge. That one I should calculate it. I will take that as a x. Okay. Here in the left hand side it has a 6 coulomb, and in right hand side it is a 5 coulomb plus x. So x is equal to, I am getting 6 minus 5. Okay, 6 minus 5 coulomb, that is equal to 1 coulomb. That means after shaking, the third charge value is 1 coulomb only. If you observe, before shaking and after shaking the isolated system, before shaking and after shaking the isolated system, there is no any changes in value of the charges, right? Before shaking it has a 6 coulomb of charge. After shaking also it has a 6 coulomb of charge. That means there is no any loss of charges takes place by shaking, right? And also there is no any charges are created also here. So that is a conservation of charge. Suppose that if I give another example of this conservation of charge, for this conservation of charge, we already know that charging by friction. In that method, we rub one body with another body. Because of rubbing, charges will transfer from one body to another body. When the charges will transfer from one body to another body, there is a loss of a charge in one body, but there is a gaining of charge in another body. If you observe, there is no any loss of charges takes place, and only the transfer of charges takes place there, and there is no any creation of new charges also. Then that property is called as conservation of charge. That means we also define conservation of charge as charges neither created nor destroyed but transferred from one body to another. That is called as conservation of a charge. This one we will observe in the charging by friction method. Okay, so that is the another property of a charge. Now we will discuss the third property of charge. That is nothing but a quantization of charge. Quantization of charge. Here the meaning of term quantization is nothing but anything that is available in a fixed amount. That is called as quantization. Then what is the meaning of quantization of charge? Quantization of charge is nothing but charges always integral multiple of E. Charges always integral multiple of E. then it is called as a quantization of charge. It is denoted as Q is equal to N into E. Here Q is nothing but the amount of charge. Amount of charge. N is an integer. E is fundamental value of charge. Fundamental value of charge. And its value is constant, that is nothing but E is equal to 1.602 into 10 to the power minus 19 coulomb. Okay, so that is called as quantization of charge. This quantization of charge gives the idea about how to calculate the amount of the charges present in a body. Okay, so by example, now we will discuss this quantization of charge. For example, if I want to purchase 3 books, okay, I want to purchase 3 books. Here, 3 books are the fixed quantity. I am not going to ask 3.5 books, give me 3.5 books, give me 2.5 books, like that. I want to purchase one fixed quantity of book, that is 3 books. Okay, here 3 means it is a fixed 3 books, and each book has one price, right? That price may be, for one book it has one book, its price is 5 rupees. 5 rupees is the price of the one book. This 5 rupees is fixed for a single book. Understood? For 3 books, it is 3 into 5, that is nothing but 15. Right? If you want to purchase 4 books, then you will multiply 4 into 5. Right? Then 20. If you observe here, this 5 is a fixed value. So similar like E. Understood? So E is equal to 1.602 into 10 to the power minus 19 coulomb. That is the fundamental value of a charge. Similarly, here this 5 means that is the fixed value for all the books. Okay, we have to multiply that with the fixed value of books. That means how much books you want to purchase, like that. So similar like that, we are going to calculate the amount of charges present in a body. Understood? But here this n is nothing but integer, and its value varies from 0, plus or minus 1, plus or minus 2, plus or minus 3, like this. Understood? It's 0, plus or minus 2, plus or minus 1, plus or minus 2, plus or minus 3. But its value is not like 1.5, 1.8, 2.5, like this. Okay, it's always an integer. Okay, like that we are going to find the amount of charges in a body. For example, there is one system. Okay, assume that this is one system. It has one charge, that is positive charge. Okay, now I want to find the amount of charge in this body. How to find it? Here there is a formula, Q is equal to N into E. So Q is equal to, N is nothing but integer, it has one charge, so that plus 1, that is positive charge, plus 1 into the fundamental value of charge is 1.602 into 10 to the power minus 19. Then the amount of charge present in a body is Q is equal to 1.6 into 10 to the power minus 19 coulomb. This is the amount of charge present in a body. Understood? Like that. Suppose that instead of plus Q, that means instead of positive charge, if there is a negative charge, then I have to multiply this with minus 1. Minus 1 into 1.602 into 10 to the power minus 19. Then amount of charge I will get minus 1.6 into 10 to the power minus 19 coulomb. Understood? So that is the another property of charge. These are the 3 main properties of charge. Other than this, some other properties also there. That is nothing but like charges. This is the 4th property. Like charges always repels, and unlike charges always attracts. So So this is the another property of a charge. We know that like charges always repels because there is a repulsive force between them, and unlike charges always attracts because there is a attractive force between the unlike charges. That is another property. Other than this, fifth property is nothing but charge is an scalar quantity. Charge is a scalar quantity. It is also one of the property of charge. Charge is a scalar quantity. That means the charge has only magnitude. There is no direction. So that charge is a scalar quantity. And the sixth property, charge carried by a body. Charge carried by a body is not affected by its motion, is not affected by its motion. It is the another property of charge. That means, for example, if I consider this pen is made up of so many charges, right? If I move this pen, then charges also move. Because of motion, there is no change in amount of charges which is present in this body. That means the motion of this pen will not affect the amount of charges present in that body. That means here there is no any loss of charges takes place, or any new creation of charges takes place because of motion of this body. So that is the another property. Charge carried by a body is not affected by its motion. Okay. So these all are the some important properties of charge.